So hopefully in the next 20 minutes or so, I'll convince you that AI is already at the center of knowledge work, how knowledge work is done, including domains that we don't think of as powered by AI. Yeah. I'll share some of the lessons learned and hopefully generate some insight to inspire some new ideas. So just a word about Thomson Reuters. Not many people sort of know what Thomson Reuters is. We are in the business of providing information and information-based solutions for professionals, legal, tax, and accounting. And also we have the Reuters part of the business, which is probably the oldest news organization, 165 years old. And every day, about 1 billion people read or see Reuters news. Yeah. So if I ask people in the audience to list 5 industries that are data-driven and powered by AI, probably I'll hear financial industry, healthcare, even the restaurant business. I'm not sure how many people will say legal. And that's surprising because common law systems, if you think about it, are by definition data-driven. Judges must find the law, must follow the law before they offer new and creative interpretations of the law. Yeah. So the collection of cases, statutes, regulations, and other legal data collectively is the data that drives interpretation and analysis of the legal systems. Yeah. And the role of solution providers like Thomson Reuters and like others is to optimize the process, the practice, and the business of the law. Not just the practice, but also the business, because at the end of the day, that's what it is. And to do that, we enhance and connect and organize content. We deliver it, make it available. We enable data-driven insights. So ultimately, we can optimize sort of through automation and augmentation and knowledge management, kind of scale knowledge workers. And sort of the second point that I wanted to make is that in any vertical industry, when you think about it, AI applications have 3 key ingredients: content, subject matter expertise, and technology. Content or data is key. It's sort of the input to the machine as well as the output from the machine. That's what people come to us for in the first place. Yeah? And by content, I mean accurate, comprehensive, enhanced, connected content, and lots of it. I lost the slides over there. Okay, so I can see them there. But subject matter expertise is also necessary because it ensures that we solve for the right problems. It ensures that we are able to capture the nuances of a domain in a way that we can compute over. And also it's needed for training and validating the algorithms. And then technology or AI, that's how we build applications. So with that in mind, I want to start with the legal domain and demonstrate how it is data-driven and the role of data and AI in legal practice. And to demonstrate that, I will build a solution architecture. Very simple solution architecture, consists of 3 layers: data, metadata, and applications. And then all of these layers interact with and depend on technology. So let's just fill it up a little bit. In data, we have primary law, cases, statutes, and regulations, and so on. We have analytical law, which is content that explains what the law is and helps people in the practice and provides such a practice guide and know-how material. We have transactional law and filings and so forth. And we have news, as well as data that is generated from the business of law, time and billing and so on. Yeah. Then in the metadata layer, we have things like authority files, the entities and organizations that are involved in legal disputes. We have relationships between these entities and so on. We have dictionaries, lots of taxonomies, literally dozens and dozens of taxonomies, topical taxonomies that we organize the law, to organize the law, knowledge graphs, citation graphs, and so on. Let me maybe just explain some of the things that happens to a case law document, just to make this more concrete. So given a case law document, the first thing that we do is zone it. This is the heading, this is the judges and attorneys paragraphs, this is the background, the history, this is the analysis, this is the decisions, and so on. We extract the entities, who is suing whom for what in front of a judge, represented by whom, when, where, all that stuff. Yeah? And we resolve each of these entities to the authority files. And then we extract terms of art and concepts. Some of them are legal terminology, some of them are medical terminologies, injuries and diseases and medical procedures and medical doctors and all that stuff. And then we summarize, identify the issues that are discussed in a legal document, and for each of these issues, we write a summary that talks about what that issue, normalize the language a little bit, and then we assign it a topic. And for that, we have a topical taxonomy of about 100,000 nodes. The law is known to be nuanced, so it's 100,000 topics. And then we do citation analysis. Those are algorithms, the citation, all that stuff. For every citation, we determine what's the reason for the citation. So when a document cites another document, it's not citing it at the document level. It's issue-based citations. And that issue is assigned a topic. And polarity. Am I agreeing with the analysis, disagreeing with it, following it, refusing to follow it, et cetera, et cetera. 300 levels of polarity. So our citation graph is sort of issue-based citation graph with topics and polarity. So that's just one example for a case law documents. And multiply that by hundreds of things that happens. And then here are some of the algorithms that we use. Yeah? And again, all of these things are standard algorithms. Thank you. And so the innovation is really adapting and extending the algorithms and the machine learning tools to our data and domain. And finally, the application, and we have literally dozens of applications. I've been doing this for 25 years, and we used to call it machine learning, and I agree with the previous speaker. There's some hype around AI, and I prefer machine learning myself. But so I organize them around 9 topics or types of applications. Research and discovery, which is about the findability problem, how to satisfy an information need through a combination of search, recommender system, and navigation-based discovery. Knowledge management, business of law, due diligence in the context of an M&A transaction. You want to understand what you are buying. And if they have 10,000 documents in their contracts, in their filing cabinets, 10,000 contracts, you don't want to read every single one of them. You want machines, algorithms to help you analyze these 10,000 documents, and so on. So this architecture as it stands is not complete because it's not responsive to some of the demand in the market, both from our customers as well as the legal tech ecosystem for integration and co-creation and so on. So directionally, we are adding a platform layer where that platform, from a technology perspective, is certainly a way of building applications, but it's also a way for us to make APIs for data, applications, functionalities, and AI available for third-party innovators to use and build applications. And for me, the more difficult question is around a platform as a business model, and a platform as a marketplace. We are trying to figure this out. So that's for the legal space, and I'll give a couple of examples to make this a bit more concrete. And then in the tax and accounting, directionally at least, some of the opportunities are similar. Research and discovery, for example, knowledge management. Some of them are different. Compliance, audit, and risk. And again, making sense of documents that our clients upload, documents in my document management system, and so on. So with that, let's jump to the use cases. I have two, or case studies. I have two of them. One is around question answering for the law, and the other, we call it Reuters News Tracer, which is about discovering newsworthy events. Yeah. So question answering. Okay. systems that are able to answer natural language questions. And as you may already know, probably or for sure you know this, there are many question types: factoid questions, definition questions, questions that need to be computed, analytical questions, logical questions, and so on. And these questions are often against different content types: structured, unstructured, multimedia, numerical content, and so on. So for us, at least for the first part of the solution, instead of focus on which question type to solve for or to address, we define the problem as focus on the questions that people ask on our legal research platform, Law. And we get about a few million queries every day. And we analyze 5 years of query logs, so you can sort of understand, do the math, a few hundreds of millions of queries, or a billion plus, billions to 2 billion, something like that, of queries that we analyze. And then instead of computing answers for this one, it's really about finding answers. And we focus on questions that require a concrete answer, an answer that is maybe a paragraph, as opposed to an answer that is, a 5-page document. So here are some example questions and answers. Is an addiction a recognized disability under the American with Disabilities Act? Is a hotel room a dwelling for purposes of Belgian statutes? And you can read them, yeah? And as you can see, these are not simple questions. Who is the President of the United States? Which country lies to the south or north of another country, and so on. These are very nuanced legal questions. And here are the answers that the algorithm found, the solution found, yeah? So drug addiction that substantially limits one or more major life activities is indeed a recognized disability under ADA. I did not know that, by the way. But it's interesting. Now here is the trick. The first two answers are correct, and the second two answers that our solution found are wrong, even though the overlap between the words in the question and the words in the answer is 100%. All the words in the question are in the answer. And again, to demonstrate that these are very nuanced questions. So, and here is the second part, which is questions over structured data, which is also deployed as in production. And we focus on 3 kinds of questions. Find the questions, whether I want to find a single document or a collection of documents. For example, find the age discrimination case decided in the last 5 years in California. Yeah. Analytical questions, example being, how often does a certain judge grant a motion for summary judgment? Where you find all the data, and then you run some analytics, and instead of just giving a number, we use natural language generation to generate a narrative about that judge, about how he or she sort of compared to his peers in that jurisdiction. And finally, comparative questions. How does Judge Sondheim opinions compare to other judges in the Minnesota District Court? Yeah? And that's sort of the second part of the question answering system. So the point I want to make is, AI is already here. It's driving, this is all in production, by the way. It's driving significant value. And the trick is to know when not to answer a question. So when we answer a question, when the system provides an answer, we are in the high 90s in terms of accuracy. But it only answers about 60% of the questions. So it has the power to know I shouldn't answer, I don't have high confidence in this answer. I should not show it to the user. And this is the solution architecture. Again, logical architecture. It has 4 sorts of processing pipeline: question discovery, question processing, answer finding, and content processing. The question discovery and content processing are done offline, and then the question processing and answer finding are done real time. And question discovery is about understanding what kind of questions we want to answer, and what are the patterns that exist in the data, and using that to help us in the next phase, which is question processing. Understanding the intent of the question, what's the question point, and then generate a series of queries that we run against the data so that we generate candidate answers, which are then sent to the answer finding to rank them, to score them, and so on, and to do question-answer alignments. And then the content processing, which is also done offline, we literally parse. If there is a sentence that we think it could be a possible answer to a question, we parse it and we structure it, because we don't want to do this heavy-duty processing at runtime. So just a couple of examples of this. So again, question discovery. And I often say the most important question in any question answering system is, what are the questions that I want to answer? Yeah? So that's the purpose of question discovery. Answer that question. What are the questions? So for example, the type system, we mine the logs. Again, maybe, I don't remember the exact number, between 1 billion and 2 billion, something maybe in the middle somewhere. Have been a couple of years since we did this, to extract, identify, and discover frames. And in AI, a frame is, think of it as a fancy word for a template that is dynamic that you can fill in the slots. Yeah. So for example, a construction of instrument template is of the following structure: is concept 1, a concept 2 optional for the purposes of a certain test. The example being, is a sleep apnea a disability for the purposes of ADA. So we discover these things algorithmically from the logs. And then the parsing, for example, does the attorney-client relationship between a corporation and an attorney extend to shareholders? Those are actual questions, and we get the answer right. The system, I don't want to use the word understands because that's too a loaded word. Quote unquote, understands that extend is the main verb. And there are two kinds of relationships between an attorney and a corporation, and an attorney and shareholders. And the question is about the second relationship. Yeah? And we do this for pretty much all sentences. Yeah? And then the training, we train it to, quote unquote, how to understand and read the law, and quote unquote, how to answer questions. And it's iterative. It requires literally tens of thousands of attorney hours. In this solution, we had a team of about maybe 20 scientists and engineers from my team, and about 15 attorneys working for about 18 months together. And we had about 300,000 question-answer pairs to train the system. Okay. What about deep learning? We released this in June of 2018. Went to production. It's going very well. We didn't do like BERT and XLNet back then. BERT wasn't out there yet. So we have been working with BERT for about 6 months now, in collaboration with University of Toronto. And the results are not there yet, but we are optimistic. So quickly, Reuters and News Tracer. You want to leave some time for questions and answers. The challenge is how to capture news at scale. Reuters has about 2,500 journalists. Still, we can't have a journalist at every corner around the world. Yeah? How to capture news at scale? Social media might be the answer. Yeah, it has coverage. It's very quick. It's fast, but we have some issues with it's not always trustworthy. Yeah, these are old examples. Pope Francis shocks the world, endorses Donald Trump for president, and releases a statement. It didn't happen, yeah? While, the SpaceX Falcon 9 explosion did happen. So how to distinguish between the two? So we built this Reuters News Tracer application. Think of it as a pipeline. It consumes Twitter feeds. It filters out the noise, chat, spam, advertisements, etc. It groups them into, clusters them into events, and then asks a series of questions algorithmically. Is this event newsworthy? Lady Gaga having a concert is an event, but it's not necessarily newsworthy for a financial analyst. If it is newsworthy, is it an assertion of fact? I saw a car accident. Or an opinion. iPhone is fantastic. If it is an assertion of fact, did it actually happen? If it's an opinion, is the entity or person or organization expressing that opinion, do they know what they are talking about? Yeah? And can do this algorithmically, and we do it when we have at least 5 tweets in about 40 milliseconds. And does it work? So you have here, when we have 5 tweets using standard rumor databases, we can distinguish between rumors and facts with 78% accuracy. If you go to 100, 86%, and so on, and then by time. And this is how it looks like. You can subscribe to channels, you can define your own channels, and so on the right-hand side, with Chuck Schumer, that event has 12,477 tweets, yeah? And you can define your own things. So, good. So with that, just concluding thoughts and remarks. Hopefully I demonstrated that AI is already driving knowledge work, is transforming how knowledge work is done. The second point, which I learned the hard way, AI exists along a spectrum. And the correlation between the complexity of my AI or your AI and value to the customer is not direct. Sometimes the most simplest features that we put out there generated the most value to our customers, and sometimes the more complex ones. So we focus on value creation, not the complexity of the solution. We talked about AI being in vertical application, data, subject matter expertise, and AI itself. And quantity of data matters, but often quality matters more. Scale, if you are leading an AI organization or team, once the business starts seeing benefits of the AI, the demand will exceed your capacity. So how to scale beyond just hiring? Yeah. And responsible AI, that's a plug-in here, a title of a book that we came out this June. I was one of the co-authors. Practice it, make sure that you have enough guidance and guidelines around, what you can and can't do, especially with customer data. And finally, at least that's my perspective from the industry that I work in, not necessarily general, the biggest obstacle to AI is not data. That's sometimes a problem. It's not algorithms. We have plenty of good algorithms. It is really the lack of creative, transformative, yet realistic use cases. And thank you so much. We have 3 minutes for questions.